Good morning, ma'am.
Good morning, Nakul.
Good morning.
Morning, Pavan. Finished, Vishal? Finished.
Good morning, ma'am.
Good morning.
Happy morning, ma'am.
Happy morning, Prasha. Did you all see your test performance at corrected answer?
I'm yet to view it, ma'am. I will view it.
Oh, okay. I'll see. LED time send it. Remind me.
Ma'am,
Good
have you
morning, ma'am.
corrected everyone's?
Good morning, Harshita. What did you say, Shweta?
No, ma'am, I didn't receive mine.
Oh, when did you submit?
Sunday itself, ma'am.
Oh, okay. Then I'll see. Finished.
Ma'am, completed yesterday's homework problems.
Yeah, we'll be discussing.
Ma'am, I did not click on submit, ma'am. I just
Oh.
realized.
Yeah, that's why I was wondering. Whoever submitted, I've corrected. So can you submit now?
Yes, ma'am, I did it now.
Yeah, sure. Only one mistake.
Ma'am, I too saw the result,
You can
ma'am.
detect that mistake. So, Prashant, what did he say?
No, just now I saw the result, ma'am.
Very good. You have done very well, Prashant.
Thank you, ma'am.
Keep it.
Good morning, ma'am.
Good morning, Santosh. Next. But I didn't give X. No, I didn't give X. You have taken X. You have to write e raised to some power. That means e raised to the same power, d by dx of the power. Action, I detected the mistake. Okay, I'll give you the clue. First six. we feel you are struggling a bit with these results, and these are giving new perspective to the results that you've already seen, right? See, the earlier results which you had seen, for example, this one, you had seen this result as x bar n, right? Same thing. So I've just changed the base x to something more generic. So that it will be applicable to any base. So the same result can be used for anything. Okay, so it will be n into whatever that base may be. We are not bothered. We use the same result, but the additional thing we take care of is that we divide the base also. If you do that, this is extendable to anything. Okay, so that's what I'm saying. So every result that you had seen last year is actually very generic. So that's what I'm trying to tell you. Okay, so that way, differentiation is very flexible, very easy, very exciting, interesting. Okay, because it can be extended to based on the basic results. But integration will be different. Okay, that's why you must learn differentiation well, okay, in order to know what not to do in integration. Okay, so let's see the results now and let's check your results. This is straight, no, dy by dx will be constant. And here, this is the result for x bar n, but instead of x, I have some other base, but the result is still applicable. The extra thing I'll be doing would be to differentiate the base. So that is the additional thing I'm doing in this class. Similarly, e raised to some power x, I know that it's e power x only. That means e raised to the same power only. But additionally, I'll be differentiating that power. Understood? Similarly, a raised to the power is nothing but a raised to the same power. Okay? But additional guest I have is log a. And then I have to differentiate the power. That is due to the chain rule that I'm using this year. Note that I'm not differentiating log a. That's the mistake, Rakshana. Understood the logic. Same thing. A power x log a is the result. So a raised to the power log a is a new result. But you have to differentiate the power. For example, suppose if you have a power x square. Okay, how do you differentiate this? Okay, let's recall that a raised to the power rule. It is nothing but a raised to the same power. That is not changing. Log a is there. And then you are differentiating the power. So that's what the law says, isn't it? So this will be a raised to the same power, log a, and then you have to differentiate that power. So what will it be? A power x square log a. The derivative of this is 2x. That's the additional thing. For example, suppose I have e power 2 power 3x. How does the law work? Same thing. Instead of a, you have 2. So still applicable. Same result is applicable, right? So 2 raised to the power 3x log 2. But I have to differentiate that power 3x. What is the derivative of 3x? 3. Yeah. 3 into 1, which is 3. So the ultimate result will be 2 power 3x log 2 into 3. That's it. So it will be 3 is not multiplying this 2 here. Okay, it is multiplying the entire function. So it is 3 into 2 power 3x into log 2. Understood how the law works? Irrespective of what the power a may be having, we are able to differentiate. So that is the beauty of these generalized results. Okay. So it is just that we know certain results. We are just trying to extend it to any power, any base, any argument. Okay, trying to generalize and extend it to any number of functions of the same kind. So log x result, you remember, is 1 by x. So log of an argument would be 1 by argument. But I need to differentiate the argument. So the additional thing I'm doing this year is that without forgetting anything other than x occurs as a power or argument or a base, I differentiate it. Okay, so that's the additional thing. So here, log of, what is the difference? 1 by argument into log A. That's the additional guessed in the denominator. But I need to differentiate the argument as usual. So I'll give you an example how this works. Say I have log x to the base 5. Okay, how do I differentiate it? What is dy by dx? Anyone? Log x to the base 5. 1 by x log 5. That's it. Because the argument is x itself, right? On the other hand, if I have something like this, log x square to the base 5. So it's not x, right? But I can still handle. I can handle it. So it will be dy by dx 1 by x square log 5. But additional thing which I'm doing is that I'm differentiating this x square. In fact, here also I'm doing it, but it's not visibly seen because the derivative of x is 1. So we are doing it. Everywhere we are doing it, but it's not seen visibly because the derivative of x happens to be 1. But here that wouldn't be the case, isn't it? This is 1 by x square log 5 and derivative of x square is 2x and this x will get cancelled. So I'll get 2 by x log 5. So this applies to anything, okay? So I can have any number of examples like this. For example, I want to differentiate log of sine x to the base 10. How would I do it? Can anyone help me with that? Any online student? Let me see how they participate.
1 by sine x log
1 by sine x?
log 10.
Log
And
10.
cos 6.
Very good, very good. Yes. Try, you're not traveling now?
Yes, ma'am.
You're traveling. Okay.
Yes, ma'am.
She's going for a dance program. She's a dancer actually. Just like Shweta. Okay. Understood, all of you? So the result for log x to the base a is applicable for anything. Follow? Did you take down? Just take down a few cases, then you will get a hang of it.
Ma'am, here in sin x, the x also is differentiated, yet it is not seen since it's 1.
1. Had it been sin x square, my result would have been cos x square into 2x. There also law is applicable.
Got it.
Yeah, there can be many number of functions composed. Here, sin x and logarithm are composed, but it can be, okay, I'll slightly modify, you try that, same function, I'll slightly modify. Try this.
Ma'am, 1 by root of sin x log 10 and 1 by 2 root sin x and cos x.
Good. There is no doubt you did, absolutely according to the rule book. Let me see whether there can be better way of doing it. Okay. Yeah. But what Nakul said, I'm sure most of you would have done the same thing. So that's how the rule works, right? So 1 by root sin x log 10. Then what did he say? You need to differentiate root sin x, right? After that. So it will be 1 by root sin x log 10. And root sin x is governed according to what? Something, base raised to some power half. No? Sin x raised to the power half, right? So some base raised to the power half. So it will be half into sin x raised to the power half minus 1. But base is not x, no. So that's what Nakul said. So he said...
root sin x the whole power half minus 1.
That's it. So this is log 10 and then this is half into 1 by root sin x And derivative of sin x is cos x. Yeah, I perfectly agree. How many of you did it this way and got it? That means you're getting used to this chain rule. But I have a better suggestion. Shall I tell you? Most of the time, this happens because students fail to see how easy is this problem actually. Because log of root sin x to the base 10 is nothing but half of. Do you all know this?
Yes, ma'am.
See, I don't know for how many of you this idea actually occurred. It's root sin x. So what I'm saying is, suppose if we have, say, log root b, okay, to the base a. Okay, how do you write it actually? I think some of you know the rules of the logarithm. Right? What will happen to the power? It will become
The
multiplier.
coefficient.
It will become a multiplier before the log. It is as simple as that. So that means what? What I had given you is a small modification of the previous prop. It would have been half of log sin x to the base 10. So I've seen this happening. Even in the board exam, many students do not understand certain basic rudimentary ideas on logarithms. So they spend a lot of time. Of course, I'm not saying all this is wrong. You know what? If you simplify the answer given by Nakul, that is nothing but 1 by 2 sin x, right? Root sin x into root sin x is what? Sin x into log 10 into cos x. So
Cot x by 2 log
cot
10.
x by 2 log 10. And this is exactly what you will get here also by considering it to be half of. Okay, because the earlier result was cot x by log 10, right? Half of it. Did you all see? Without the root, when I had given the problem, the same problem when I had given it without the root, the answer was cot x by log 10. With the root, when I gave, it became cot x by log 10 into 2 in the denominator. So that half, how did it occur? But that's because of root sin x. Okay, that sin x root will come out as half. So that means when you have certain functions involving log, you must think of certain rules of the logarithms, simplify the function to the extent possible, and then try to differentiate. Then it will be easier for you. Okay, so coming to the standard results, sign of an argument. Okay, can someone say dy by dx will be? Cos of the same.
Cos argument.
Same argument. Argument does not undergo any change. Okay, but the additional thing you are doing is you are differentiating the argument. Okay, so similarly, always remember cosine, cotangent, cosecant, all these will have negative sign. Okay, you can even put them beforehand.
Could you just show the other column for a second?
Which one?
The other column.
This one?
Yes, ma'am. Thank you. Yes, ma'am.
Tan.
Secant square argument.
Good. Secant square of argument into d by dx of the argument. So cosecant square of the argument into d by dx of the argument. So secant will be secant and tan. Oh, secant and tan. Secant and tan of the same argument. But separately, argument should be differentiated. Similarly, this will be cosecant and cot of the same argument. Note that argument doesn't undergo any change when it is attached to the corresponding functions. The additional thing which you are doing is finding the derivative of the argument, right? So some students, you know what, they differentiate the argument and put it here itself. That will be meaningless. That wouldn't change. Okay, so that's the way you sometimes misinterpret the result. Okay, so now let's see the homework which I had given. Hope you could attempt those problems. Can you read out the problems? Yeah. Can someone read out the answer to this? Subtraction. Cos root x into derivative of the root x, right? So derivative of root x will be 1 by 2 into x power minus half. Did you all get it? Of course, you can modify and write this as 1 by 2 root x into cos root x. How many of you got the first problem right? Raise your hands. 1 by 2 root x cos root x. Okay. Next one. Who's ready? Anyone? First of all, which law?
Base.
Very good. Base raise. Shivanandana, can you attempt?
4 into x square plus cos x to the power 3.
3. Very good.
Into 2x minus sin x.
Okay. Excellent. You understood it perfectly well. 4 into x square plus cos x power 3 into derivative of this, which is 2x minus sin x. Very good. Who's ready with the third one? Okay, both you got correct. Are you ready? Sai. 1 second, ma, I'll just copy down. X into cot square x, no? X into cot square x. But basically, look at it. The bird's view of this tells you that it's a product, basically. That means the product rule will become a priority now. Even before you can think of any chain rule or anything, that it is a product will be overwhelmingly, attention seeking. That is the first law to be applied. Priority. Okay, so your dy by dx would be u into v dash plus u dash into v. So that's how it should be viewed. So x into cot square x dash plus x dash into cot square x. So differentiating one at a time and keeping the other as a constant. Okay. So now Sai will help me to differentiate cot square x. So what law will prevail, Sai, for this? Cot x power. Very good. Base law. So this is nothing but this is cot x power 2, which I am trying to differentiate. Hope it's clear. Cot square x is nothing but cot x power 2, right? That is base law only. Go ahead. Base raised to the power n. How do you do it? Very good. Yeah. 2 into cot x power 1. It's not differentiation. Okay, don't be carried away. Cot x power 1 into d by dx of cot x. Yeah, d by dx of cot x plus 1. Very good. Derivative of x, which is 1, into cot square x, unaltered. That's not getting differentiated. Okay, can you help me further? So this will be x into 2 cot x. Very good. Minus cosecant square x. That is plain differentiation without any chain rule. 1 into cot square x, that is cot square x. Okay, so altogether, the first term becomes negative. Minus 2x cot x cosecant square x plus cot square x. Of course, if you want, you can simplify further by taking cot x out. How many of you got this answer? Raise your hands. Very good. Others, can you note down and where you went wrong? Just observe that. Avoid the mistakes in future. That's going to be important. X cubed into tan square x. X cubed into tan square x. Can anyone take this up? Avinash, can you try? Okay, anyone else? Nakul, can you try?
Yes, ma'am. Ma'am, this is UV rule, ma'am.
Good.
Product rule.
U into V dash plus U dash into V.
Yes, ma'am. 3x square.
Oh, you are differentiating.
Okay, yes, ma'am. Tan square x.
Yeah, let me prioritize what I'm doing. So I'm just replacing them with the respective things. Go ahead, go ahead.
Yes, ma'am. X cube into secant. 1 second. Two secant square 2x.
This is tan square x. No. Tan
Yes.
square x is what? Tan x the whole square.
Sorry, ma'am. 2 tan x secant square x.
I am sure you would have meant that only. So 2 tan x into derivative of tan x.
Secant square x. Yes.
Plus.
Plus 3x square tan square x.
Good. Of course, you can simplify to any extent you want. You can take x square tan x out if you want. Simplify the rest. So that's fine. How many of you got this correct? Fourth one? Really correct. Very good. So note that from now on, every day, you will be making very huge strides in differentiation. That means every minute your differentiation skills will be growing at a very fast rate. So you should get accustomed to the rules very fast. Only then you can cope to what is to follow. Next one. Secant x into e power minus x. Who's ready to take it?
Ma'am, can I try?
Yes. Secant x into e power minus x. So how do you read it? Into. Okay, so which law?
Product.
Product law. So dy by dx will be basically say pressure.
U V dash plus V U dash.
Very good.
So that would be secant x into e to the power minus x into minus 1.
Okay, the dash I'll put later on.
Okay. E to the power minus x, secant x dash. So that would be secant x into e to the power minus x into minus 1. plus e power minus x into secant x tan x.
Good job. Good job. Perfect job. Very good. So did you see he has carefully differentiated minus x here? Okay, so which has been found to be minus 1. Of course, you can take e power minus x out, and e power minus x and secant x also you can take out and simplify this. But hope you got the skeleton form of that. So how many of you got this right? Got it right entirely. Sai, could you do? Small mistake. Okay, let's see the 6th one. Tan of root x minus root of cot x. Tan of root x minus root of cos x. Okay. Is there any rule as such? I mean, like product rule,
No.
subtraction rule. Subtraction rule. Y is a difference of two functions, right? So the news is that when you differentiate such a function, the minus sign is preserved. Minus or plus sign will be preserved, and you may have to differentiate the individual functions. That's all there is to do. Understood? Whenever you have plus or minus sign, all that you need to do is preserve them when you differentiate. So differentiation is unaffected by plus or minus. That means the differentiation of the sum will be sum of the differentiation. The differentiation of the difference will be difference of the differentiations. Right? All right. Who is ready? Tan
Ma'am,
root.
can you try?
Come on, Raya. Come on.
Yes. Ma'am, so the first term will become secant square x into 1 by 2 root x.
Can you say again? Secant square?
Secant square root x into
Very
1 by 2 root x.
She won't make mistakes. She's very smart. Into derivative of root x.
Yes, ma'am.
Very good. Next.
Ma'am, and the second term will become minus sin x by 2 root cos x.
Excellent. Yeah, correct. Yeah. Root cos x. Root cos x is actually cos x power half.
Yes, ma'am.
It is said half into cos x power half minus 1. And then she has differentiated this base, that is minus sin x. So that's what she read out. So I was, checking it. And she was right. So what she said was 1 by 2 root cos x and minus sin x. So minus of minus will become plus, no, Rhea? Finally.
Yes, ma'am.
Very good. Flawless. Flawless answer. Minus of minus plus sin x by 2 root cos x. Very good. Very good, Rhea. Excellent.
Thank you.
Okay. Then 7th one. Cot of 1 minus x square. Yeah, straight. Okay. Cot of 1 minus x square. Who is ready? Shweta, can you say? Shweta. Or
Yes,
Ashini?
ma'am.
Anyone?
Ma'am,
Shweta is ready. Okay.
yes, ma'am. D by dx of 1 minus x square and minus cosec square into 1 minus x square.
Very good. Very good. She got it. There's a single function. That's it. Nothing else. No other rule. So only chain. Just chain rule prevails. Okay. And cot of something is minus cosecant square of the same thing. Okay. And she retained it. Did you all observe it? After that, she differentiated this 1 minus x square. And derivative of 1 minus x square is minus 2x. No? So that minus 2x and this minus 2x, they'll become, this minus, they'll get nullified. So plus 2x into cosecant square of 1 minus x square. How many of you got this? Good, good. See, many of you.
Would it be, ma'am, I have a question. Would this be minus or because we're differentiating 1 minus x squared?
So that derivative is minus 2x, right? So this minus of minus
Because
became.
minus, yes. Got it, yes. Thank
Yeah.
you.
I am interested in knowing how you did the next one. Why is?
I could apply the trigonometry formula.
Exactly. Just like whenever logarithm comes, you should be alert. Just like whenever some trigonometric function comes, because many of the trigonometric results will come to our rescue. Always remember. Okay. And there was a problem a few years back. Okay, for 3 months. Surprisingly, they asked a very basic question for differentiation, not very complicated one. They could have simplified it and got it in no time, but the students went, some circuitous manner they differentiated. Actually, it could have been simplified in a very easy manner. Now, what's 1 plus cos 2x known to all of us, right? What
2
is it?
cos squared x.
Yeah, exactly. And if you use it, you can do it in no time. That's why whenever trigonometric function comes, a logarithmic function comes, be careful. So 2 and 2 will get cancelled. And root of cot square, that's nothing but cot x. So plain function, see, no hassles at all. Cot x means what? Just minus cosecant. Did you all do it this way? That way only? Okay, because I thought maybe you'll be doing that chain rule. 1 plus cos x by 1 minus cos 2x, the whole power half. Okay, that base, some of you may be carried away by the power and you will think it's base raised to something. Log of this, who is ready? Log of 4x square plus 9x minus 7. 4x square plus 9x minus 7. Pavan, can you try?
So like 1 by log.
Very good. See, first of all, did you all see there is no rule here? I mean, no product rule, no quotient rule, no sum rule, no difference rule, only chain rule. Okay, only two functions are composed. Logarithmic and a quadratic, they are composed. Go ahead. 1 by?
1 by log.
1 by?
So 1 by 4x square plus.
How will you go wrong? Okay.
Yes, no.
Yeah. Then?
I'm confused with this question.
Yeah, so this is governed by which rule? That log of something. Log x means what, Pavan? 1 by x, no?
Yes.
Same thing is extendable to anything. So log of argument will be 1 by argument, but that derivative of the argument should be multiplied with. So you should multiply this with the derivative of whatever went down.
Okay, ma'am. Yes.
Yeah, that's it. Completed. So it will be 1 by 4x square plus 9x minus 7 into 4 comes out. Derivative of x square?
8x plus 9.
Exactly. That's it. Understood, no, Pavan?
Yes, ma'am. Now I understand.
Yeah. You can do it, no problem. Plus 9 into 1 minus 0. You just have to differentiate it term by term. Preserving the plus sign, preserving the minus sign. You just have to differentiate term wise. So what is it in the numerator? 8x plus 9. Yeah. So the overall derivative is 8x plus 9 by 4x square plus 9x minus 7. So the derivative seems to be a rational function, can't be helped. So that is how it will be whenever log function is getting differentiated. Did you all check your result? How many of you got it right? See, first of all, it's important for you to have attempted all these problems, okay? Because every day, like I told you, after 2 days, if you look back and see, you were at some other level. After 2 days, you'll be in some other level. Okay, that's how differentiation progresses. So every problem will be important. You need to understand. Otherwise, you'll be lagging behind the others. Next one. Y is x sin x minus cos x power 5 by 2. Who's ready to take this? X sin x minus cos x power 5 by 2. Did I copy it? Cos x minus sin x. X sin x minus cos x. Anyone willing to take this up? Any volunteer? Ashita, can you try? First, can anyone say which will govern this, which rule? Base raised to the power n. So if you have basically understood what is actually governing it, so you can try writing the result and then try to apply it here. Probably that will work because you are trying to learn it just now. So if you're not very sure, try to write the law and try to follow it. Anyone? Ashita. Okay, very good. Yes, Ashita.
It would be 5 by 2 into the derivative of x sin x into x sin x minus cos x into the derivative of x sin x minus cos x.
Power. Yeah, many of you forget
3
the power.
by 2 more.
Yeah.
Yes, 5 by 2 minus 1, which is
Very
3.
good. But we should differentiate this argument.
Yes, ma'am.
Yes, Hashita. Yeah, please help us to find this. This is nothing but 5 by 2 x sin x minus cos x power 3 by 2. Okay, 5 by 2 minus 1, 3 by 2. Okay, so now she's going to help us to differentiate this. What law?
Subtraction law, we can derive the two quantities separately. So x sin x can be derived using product rule.
Product law, yeah.
So it would be x derivative of sin x.
Good. X
Plus
sin x dash plus sin x into x
derivative of
dash.
x minus derivative of cos x.
Good. So shall we write it right away? Minus derivative of cos. All right. So it will be 5 by 2 x sin x minus cos x power 3 by 2. So she'll help us further. X into
cos x plus sin x.
Good. Sin x into 1. Sin x into
plus sin x.
Very good. Yeah. Minus of minus plus sin x. Cos x was differentiated. So does anything get cancelled? No, isn't it? So probably we can just combine. It will be 5 by 2 x sin x minus cos x power 3 by 2. And this whole thing can be simplified as x cos x plus 2 sin x. Exactly. Okay. How many of you got this perfectly? X cos x plus 2 sin. That is the derivative of the base. Medini, are you able to do? Janvi?
Yes, ma'am.
Very good. Janvi, have you followed?
Yes, ma'am.
Are you all okay? So did anyone get all the 10 correct? Did I give only 10? Oh, they are 3. Good job. And Diksha also. Very good. Okay, today I'll give you some more problems. Today I'll give you some more problems on chain rule because it needs a lot of practice. But let's take up the next aspect. But because once you get used to all techniques only, you can start doing the worksheet. Okay, but then I'm tempted to ask the next question. Seems to be interesting. Shall we do one or two? One or two of the MCQs? Because we have done up to this. Can you try the next one? The set of numbers where the function given by f of x is equal to mod of 2x minus 1 into cos x is differentiable. It's the product of two functions, one of which is differentiable everywhere. No? What is the derivative of cos x? Minus sign. It exists. It exists everywhere. Okay, so there is no question about the differentiability of cos x. Okay, so it is a green function. How about this? This mod 2x minus 1 is always very good. Non-differentiable. It's not differentiable. No, at what point? Very good. Half. At half, it's not differentiable. Just like mod x is not differentiable at x equal to 0. Okay. How do you come across that point? By equating whatever is within the mod to 0. Like here, whatever is within the mod, if you equate it to 0, the solution seems to be half. So that's where it's not differentiable. So the option?
B.
B. Very good. Alert. Okay, see if you can do this. If y is log of 1 minus x square by 1 plus x square, what is dy by dx? How would you like to differentiate it? What did I tell you? Whenever there is involvement of log, what should you do? Log of a by b form. What is log of a by b?
Log a minus log.
Very good, Nakul. Excellent, Nakul. Log of 1 minus x square minus of log of 1 plus x square. So this is very important for, that's why I told you, many students don't think about the rules of logarithms. Can someone help me to differentiate this? Log
Subtraction law.
Tell me how would you differentiate this?
1 by 1 minus x.
1 minus x square, but this 1 minus x square should be differentiated.
Minus 2x.
Minus 2x.
Good. Minus 2x. Minus of. Very good. 1 by 1 plus x square.
Plus
that 1 plus x square should be differentiated. Okay, can you simplify this? Of course, he has not given any of these. So he has obviously simplified this, right? So he has taken LCM and simplified this. So just take LCM and cross multiply.
Mom, numerator is minus 4x.
Very good. Very good. Yeah. Minus 2x cube and plus 2x cube, they get cancelled. Minus 2x is minus 4x by 1 minus x power 4. Look for the option. I'm not able to see. Which one? B.
Option B.
B. Is that correct? Yeah. Correct. Minus 4x by 1 minus x power 4. What is the derivative secant of tan inverse of x? Oh. All right. Secant of tan inverse. Can someone help me? Secant of tan inverse. Let tan inverse of x be some theta. It will be always theta, right? That means x is tan theta. So tan theta is x by 1. Tan theta is x by 1. What is secant theta then? hypotenuse by adjacent. Secant theta is root of 1 plus x square. What is
X
theta?
by root of 1 plus x square.
That is sine, no? Hypotenuse by adjacent, no, knuckle.
Yes, yes.
1 plus x, root of 1 plus x square. So theta is, all right. So this was taken as theta, right?
Ma'am, it would be by x, right? Because it's perpendicular. Hypotenuse by perpendicular.
What's your point?
Ma'am, I thought secant was inverse.
Secant is inverse of cos. So secant will be hypotenuse by adjacent. Right. So I got y reduced to this actually. Y was secant of tan inverse of x, but it got reduced to this. So can you differentiate this? That's what he wants. He wants the derivative of this. What law?
Yes.
Base raised to the power.
Ma'am, is the answer x by root of 1 plus x square?
I think so. Power half. Don't forget, root of 1 plus x square means what? 1 plus x square power half. So let's differentiate it accordingly. So half of 1 plus x square raised to the power half minus 1, which is minus half, into derivative of 1 plus x square, that is 2x. X by root of 1 plus x. Hello. You know what? Many students will do this by chain rule. They will take tan inverse of x as some argument. They will write secant of tan inverse of x into tan of tan inverse of x into derivative of tan inverse of x. They won't arrive at the MCQ choice. So it requires some out of the box thinking. So they obviously they want you to express it as an algebraic function. Only then options can be arrived at, right? What was the option? X by root of 1 plus x square. Where is it? Can you all see? Next one. Y is cos inverse of root x minus 1 by root x plus 1, but plus cosecant inverse of root x plus 1 by root x minus 1. Oh, it's given you a clever problem what to do. All right. All right. Before that, I would like to. Actually, the problem is simple. Shall we do? Actually, the problem appears to be tough, but it's not. Shall we do cos inverse of root x minus 1? Cos inverse of root x minus 1 by root x plus 1 plus cosecant inverse of root x plus 1 by root x. Can someone help me to express this in terms of sine inverse?
Sine inverse of the theta containing cos inverse. Like root x minus 1 by root x
Very
plus
good. Yeah.
S1 by root
All
x
of you know that, is it? Very clever. Yeah. Yeah. So just note this. Cosecant inverse of y will be sine inverse of 1 by y. That's what I used.
Ma'am, pi by 2.
Very good. Very good, Trai. Excellent. Yeah. So dy by dx is 0.
0.
It appeared to be so complicated, but if you know certain basic things in inverse trigonometry, yeah, right? So I expected you to understand. That's why I did it. All of you know that result, right? Sine inverse plus cos inverse is pi by 2. So nice problem. Log of x power 5. Log of x power 5. log of x bar. Many log functions are composed. So can anyone do it for me?
Ma'am, for the inside log, can it be 5 log x?
1 second, Nakul. Go from the outermost one. Huh? Understood? Log of
Ma'am,
something.
1 by log of x bar 5.
I'm saying read it as log of something. Huh? Log of something. What is log of something?
1
1
by
by
something.
something. 1 by something into derivative of something. So it will be 1 by log of x power 5 into dy dx of log of x power 5. Okay, now look at this where you are supposed to differentiate. Look at this. This is log of something. Okay, this is something, log of something. And what is log of something? 1 by something. Okay, this is 1 by something into derivative of the same thing. But this something is different. That's why I used a different color. Log of x power. So that will be 1 by log x power 5. 1 by something, that is nothing but log of x power 5 into derivative of that, which is log of x power 5. But log of x power 5, coming to think of it, what is log of x power 5? Now I think we can afford to. We can use some laws of logarithms. What is it?
5 log x.
So it will be 5 by x, right? Is that correct? Let's see whether he has given any such option. Which of these options?
From option A.
Oh yeah, correct. Option A. Correct. Okay, option. So I know that about 4 functions are getting composed here. Log of x power 5. X power 5 is getting composed with log, which is composed with one more log, which is composed with one more log. So several chain laws work, but basic idea is log of something only, right? Oh yeah. So for these, we require some more exposure. Yeah, okay. So let's do some inverse trigonometry today. So let us take, for example, y is equal to sin x. Okay. Then we know that dy by dx will be cos x, right? This is known to us. But if y is sine inverse of x, how to find out dy by dx? So I don't know how to differentiate inverse trigonometric functions. One way of approach may be from the first principles. Okay. Limit extending to, or limit delta extending to 0. Sine inverse of x plus delta x minus sine inverse of x divided by delta x. I can try and prove that it is something. Okay, this can be evaluated, but there is an easier way. Okay, y is sine inverse of x. So what is x? Sine y. Yes or no? Y is sine inverse of x, so x has to be sine y, right? So what is dx by dy? Cos y, very good. Cos y. I'm differentiating with respect to y, right? So, but I want dy by dx, right? I want dy by dx. So, it will be 1 by cos y. 1 by cos y. 1 by cos y is not cos inverse. 1 by cos y is secant y. So, I'm not converting it. Okay. So, dy by dx is 1 by cos y. Cos y is nothing but 1 minus root of 1 minus sine square y. And sine y is nothing but x. So, 1 minus x. And this is what yesterday Pavan gave us all. Remember? I gave the function y is equal to sine inverse of x. Immediately he said derivative is 1 by root of 1 minus x square. Do you all remember this? Yesterday he gave this result. Same result I'm arriving. Okay. Take. This is how the derivative of inverse trigonometric functions are arrived at. What do we do? From inverse trigonometry, we go to trigonometry. But for a change, we differentiate with respect to y instead of differentiating with respect to x. Treating x to be a function of y. Can't be helped. Because when y is sine inverse of x, x is sine y. X is actually explicit. Did I invert here? Did you see dx by dy is cos y? So dy by dx, the reciprocal. Okay, reciprocal is 1 by cos y. Again, cos y I'm trying to express in terms of sine y because sine y is only x. So what did we start with? We started with y is equal to sine inverse of x. And what did we end up getting? Dy by dx is 1 by root of 1 minus x square. So let's note down this. When y is sine inverse of x, your derivative is 1 by root of 1 minus x. So this is the basis for that. Can you try and remember this is the first amongst the results that we are about to see today? And cos inverse of x, the derivative of cos inverse of x will be, guess?
From 1 by root of 1 plus x squared.
X squared minus 1.
1 by root of x into 1 minus x squared. Root of 1 minus x.
Minus 1 by root of 1 minus x square.
Exactly. Yeah. See, don't you know that this result, sine inverse plus cos inverse is pi by 2, right? Do you all know this result? It's a very important result in inverse trigonometry. I hope you remember that. That means what? The derivative of sine inverse plus the derivative of cos inverse will be the derivative of pi by 2. But what is the derivative of pi by 2?
0.
0. Very good. Yeah, pi by 2 is a constant, you see. So sum of these derivatives is always 0. That means what? The derivatives must be opposite. Otherwise, it won't happen. Did you understand? So if I tell you that the derivative of tan inverse of x is 1 by 1 plus x square, won't you be able to guess the derivative of cot inverse? Exactly.
Minus 1.
Because again, their sum adds up to pi by 2, right? What if I told you the derivative
1 by mod x, 1 by mod x root of x square plus.
Very good.
X square minus 1.
X square minus 1. Yeah. And yeah, valid in appropriate domains, of course. Okay. That goes without saying. For example, here I expect x to be between minus 1 and plus 1. And here I expect x to be not belonging to that interval. Otherwise, it wouldn't be well defined under the root. So it will be r minus of minus 1. Yeah. I'll remove the closed interval because x can't even be 1. Right? X can't be 1, no? X can't be 1 in the denominator. I'm removing it. And also all the fractions. Fractions should be removed. Otherwise, I'll have under the root negative sign. Here, x can be any real number. right? It's valid, no? So in the appropriate domain only, we know this is the domain of secant inverse of x as well, right? All of you know that? That's the domain. So can you write the derivative for cosecant inverse?
Minus 1.
What will be that? Exactly, same. Minus 1 by mod x into root of x square minus. Maybe thinking, why am I introducing suddenly a mod function here? That's because I don't know what x is. X can be positive or negative, but I very well know that secant inverse is an increasing function. Okay, so later on I'll be dealing with that concept. So secant
Ma'am,
inverse, its derivative should be positive. That's why I'm insisting on this x being positive by imposing a mod. So you have to impose it as well. So mod
ma'am,
x.
so for every inverse function, their domain would be their, I mean, the x values will be the domain itself.
Obviously, no, otherwise how will they exist?
Yes,
For
ma'am.
example, suppose I find out sine inverse of x when x is 2, right? First of
Or
all,
it'll be negative in the
yeah,
denominator.
first of all, I'm doing an absurd thing. Sine inverse of x when x is 2 is something that we can't think of, right? So derivative also won't exist. Because if the function itself is not existing. So the derivative, how will it exist? It has got some relevance to the domain. Understood? Because here of course there is a trouble for the derivative at 1. In fact, the derivative will exist only in the open interval. I think I mentioned this to you briefly in one of the classes. Here x is belonging to closed interval, right? But the derivative excludes that 1 and minus 1 because the derivative suffers from discontinuity at that point. Can't be helped. So sine inverse does not possess the derivative at 1 and minus 1. Elsewhere, it is differential. Do you follow this? And for the same reason, when x is 1 or minus 1, your derivative is not defined, but secant inverse is defined. Okay.
Yes, ma'am.
Okay. So take a fresh page and try to write these results after that papers. Okay. Try and write all these results in one place. This is going to be a test for you. Let's see whether you recall derivative of inverse trigonometric functions. Okay, can someone read out your result? Let me see if you remember. Who is going to
1
read?
by
1 by
root of 1 minus x square.
okay. Santosh, second one.
Yes, ma'am. Minus 1 by root 1 minus x square.
Okay. Hashini, third one.
Ma'am,
Third result, tan inverse.
1 by 1 plus x square.
Okay. Medini,
Minus 1 by 1 plus x square.
Pavan, secant inverse.
1 by x mod x root of x square minus 1.
Prashant, last one.
Ma'am, minus 1 by mod x root of x square minus 1.
Could you all get this? Okay. Now we'll pose some simple problems. See if you can do them. For example, y is sine inverse of cos x. How would you differentiate?
Now we substitute x in place of cos x in place of x.
Okay, do it and see.
Ma'am, is it cosecant x?
You are right. Prashant, what did you say?
Cosecant x, ma'am.
Oh. What is sine inverse result? Sine inverse result also can be generalized. Sine inverse of an argument is 1 by root of 1 minus argument square into derivative of the argument. So the results that you wrote just now, they're valid for any argument, not necessarily x. Okay, can be extended as well. So dy
But we are not multiplying the result of sine inverse x with 2x, right? Like minus
Ma'am,
2x.
is it plus or minus 1?
which is plus or minus 1? I'm using this result, right? So
You told we have to multiply it with the derivative of the argument.
Argument is cos x, right?
But while writing for x square itself in sine inverse x that we have tabulated, we should have multiplied it with minus 2x, right?
We should have multiplied with the derivative of the argument. What is the argument?
Ma'am, is it minus 1?
See, whatever comes after sine inverse, that is called the argument, no, Prashant? That argument only I am differentiating.
Yeah, got it.
So 1 by root of 1 minus cos square, that is nothing but sin x. And derivative of cos x is minus sin x. They get cancelled. I get minus. See, but I didn't apply chain rule. I merely applied the fact that cos x is sine of pi by 2 minus x, right? Sine inverse and sine, they get nullified. Why is this? So derivative is minus. Did anyone do it like this? You didn't. Try. You did it?
No, not that way.
Not this way. Okay. I was really surprised. Okay, can you try one problem like that? Sine of tan inverse of x. Okay, let me see how you do it. It's up to you to do it in any manner you like. Avinash, what's your answer? Yeah, that's one way of doing it. So what Avinash has done, what is this actually? He has interpreted this as sign of something. Okay? Understood all of you? Sign of argument, whatever. Sign of an argument. That will be cause of the same argument, cause of the argument. But you have to differentiate the argument. That's what he has done. Straightforward method. So cos of tan inverse of x into derivative of tan inverse of x, which is this. What if this is not given as an option? Say if they give you some algebraic options, you can take tan inverse of x as theta. So y is sine theta. So tan inverse of x is theta, so x is tan theta. X is tan theta. So what is sine theta? X by root of 1 plus x. So if you differentiate, you will get the options that he gives. Okay. That's another way of doing the problem. This problem, actually, we can convert it to this. Take down.
Yes, ma'am, I converted it.
Then he can choose in case he gives some other option, because these can come in MCQ. You should be able to handle it irrespective of what answers he gives. Okay?
And we should differentiate y, no? So should it be cos theta or sin theta?
No. We have to differentiate it using ordinary laws. Like
Oh, this you should what if we differentiate this, then go to the...
I'm
So
using quotient law.
so here we have cos tan inverse x, right? So what if we substitute that as cos theta?
Oh, but dy by dx won't be cos theta, right? Dy by d theta will be cos theta, but that's not what.
Okay.
This y is equal to x by root of 1 plus x square is obtained by converting tan inverse x into sine inverse x by root of 1 plus x square.
Sine of tan inverse of x, I converted it into entirely in algebraic form. After that, I'm using quotient law to resolve.
Okay.
This would have been the option after simplification. If you cross multiply and simplify, take it to the denominator, this would have been the option. But many students can't handle it. Actually, here itself we can do it. This is nothing but cos theta into 1 by 1 plus x square. But cos theta in this triangle, what is cos theta in this triangle?
1 by root
of 1 plus x square.
yes, ma'am. This is what I will.
Okay. That also is possible. Yeah, we could have done it this way also. Understood? That would have been an entirely algebraic option. Yes? So, let's see another possibility. Y is e power sine inverse of x plus 1. How would you do it?
Ma'am, it's chain rule.
Yes, very good. Yeah, chain rule. So, e raised to some power. Okay.
It is the same.
Yes, it is the same. So, e raised to the same power. But the thing is, I have to multiply it by the derivative of it. So, if I apply that, it is chain rule. Okay, I'm glad you could associate that with chain. So, dy by dx will be e raised to the same power. So that is the exclusiveness of exponential functions. But they retain the same power, but the power which is other than x, should it not be differentiated? Should be, no? So can you come to my rescue in differentiating that? What is the derivative of sine inverse? Sine inverse of something.
1 by root of
1
1
by
minus
root
x
of
square.
1 minus of that something
X
the
plus
whole. Into derivative of x plus 1, of course. Because it's not x, it's x plus 1. So it should be differentiated. But here there is no impact because it's 1. Did you get it? So derivative of this. That's how it is. Pure chain.
Yeah, derivative should not be differentiated because under root is a negative.
Under root?
It's a negative.
How do you know?
Because x plus 1 over square is 1.
Possible.
It can be greater than.
It can be fraction also.
But still, yeah.
What is the appropriate domain for this? It's a fraction. X plus 1 is a fraction. So it exists.
If we have x, it can also be negative.
It can also be negative. Nothing wrong. See, everything is logically connected, no? So you wouldn't have anything that is illogical. Because everything is associated with domain, and from that only we get it. So what is valid in the domain should be valid in the derivative also. So nothing abnormal.
Mom, if y is a function such that its sine inverse of a constant, does that mean its derivative does not exist?
Derivative will be 0.
Oh.
1 second. Are you all planning to do it by chain rule? Chain rule? Then. If not chain rule, what is it?
1 plus x into cos.
Better suggestion. I don't want you to use chain rule. That will be tedious. Instead, I want you to use a smart method. Because you know inverse trigonometry. You also know reasonable trigonometry. Tell me, what should I substitute for x? Let x be. Let me see who's brilliant.
Cos x.
Very good. Cos theta or cos 2 theta, anything will work. Understood? Let's see how it works. See, we have done many simplification problems in inverse. That should come to a rescue now. That was a brilliant suggestion, Prashant. What is 1 plus cos theta? What is
2
1?
cos square theta by 2.
Yeah, that one. That will help us to get it out the root. Look at that. It's much better than, struggling with the chain rule. All right. Theta by 2. What is theta? What is theta?
Cos inverse x.
Very good. See how, easy it has become. So what is dy by dx? Half will come out. Who remembers derivative for cos inverse? Minus 1 by root of 1 minus x. Otherwise, you would have struggled, using chain rule. It would have been very tedious. Whereas substitution makes the job simple. Okay. So can you think of appropriate substitutions and do? I'm going to pose some problems based on that idea, where we reduce the given inverse trigonometric function using a suitable substitution. So can someone come out with a suitable suggestion for this? Some trigonometric substitution.
From cos theta again.
From sine theta?
Sine theta is better. Try. Of course, cos also will work, but it wouldn't be compatible with the domain.
You get 2 theta.
Good job. Good job. Very fast. Try. Good job.
Ma'am, 2 by 1 minus x squared.
2 by?
Root of 1 minus x.
Good job. Very good. She finished it. Very good. See whether you all got. X is sine theta. And this is root of 1 minus sine square. That will be cos. What is 2 sine theta cos theta? That's what she said in the very beginning. It will become sine 2 theta. Right? Hope you all remember that. Sine inverse of sine 2 theta is 2 theta. But it calls for resubstitution. Because x was sine theta, theta will be sine inverse. Now it is conducive for differentiation. That's what she said as the final answer. All right. Try this.
One 3 theta.
Substitution. Very good. Avinash said cos theta. Try all of you.
3 theta will get.
Very good.
Minus 3 by root of 1 minus x squared.
Minus, no?
Yes, ma'am. Minus.
Yeah, we are brushing up inverse trigonometry nicely today. So, cos inverse of cos 3 theta, closed form, 3 theta, resubstituting. It is 3 times cos inverse of x. So, dy by dx will be negative. Think of some suitable substitution. Good job. Great suggestion, Rachana. Excellent. Okay, come on. All of you substitute what she suggested. Then what? Hope you all reach this stage. Express in terms of sine and cos. Let's multiply through it by cos.
Minus 1 by sin theta.
1 minus cos theta by sin theta, right? No, this will stay, no, Trai.
Yes, ma'am. Yes.
Yeah, that will stay. After that, who's going to help me? What is 1 minus cos theta? Popular. 2 sin square theta by 2. Sin theta. 2 sin theta by 2 cos theta by 2. See how nicely Rakshana suggested, how it has helped us to get such a beautiful closed form.
Theta by 2.
Very good. Yeah, tan theta by 2, that is nothing but theta by 2. So y has been reduced to such a sweet expression, theta by 2, cute. Okay, but what is theta? Tan inverse of x, very good. Because x was tan theta, right? Okay. Many students get so excited at this stage, they stop the problem, but you have to differentiate. That is yet to be done. Okay. So half will come out. And who remembers derivative of tan inverse?
1 by 1 plus x squared.
Now I'll give you some thought-provoking problems for homework. Can you try? Some 10 problems? Homework. Let's remember the page, 158. No substitution needed. You can straight away simplify and do it.
I'm first to a now only we did.
Huh? Oh, yeah.
Yes, ma'am.
Yeah. No substitution. No substitution needed. We'll discuss the answers tomorrow. Tomorrow, same time. Okay? See you.